Okay, so this is about the practicals of chemistry. Okay, so this is in the syllabus of 2021 CBSE boards of chemistry class 12th, and it includes volumetric analysis, which is also known as titration, for the 8 marks, salt analysis for 8 marks, content based experiments. It includes functional group, chromatography, and carbohydrates, fats, protein, those tests. It includes 6 marks. Project work includes 4 marks. Class record, you means class, how you behave in class, how you studied well in class. And a viva is also related to the project work and of your these experiments. Then it's of 4 marks and it's of total 30 marks. As you all may know that your chemistry marks are total 100, 30 from here and 70 from theoretical portion, a theoretical exam, which will be held on from 4th May this year. So first expression, these are the some points which you need to look upon a day before or night before the final practical exams. So first expression is a file. So your file should be at the point, it should be top-notch file. And then second impression is of the behavior, how you behave there in the class, in the practical examination hall. And the third impression is of viva. Viva means it can be asked from project or any chapter of the theory. थ्योरी में जैसे नेम रिएक्शंस हो गई, फिजिकल चैप्टर्स में फिजिकल केमिस्ट्री में जैसे फॉर्मूलेज हो गए, इनऑर्गेनिक में मे बी सम एक्सेप्शंस लाइक. Then we come next to the main 3 experiments which to be written in an answer sheet. Okay, so first is of this is wrong. First is of titration. Titration is of 2 types. It is of KMnO4 with oxalic acid or KMnO4 titrated against more salts. Okay, then we come to the salt analysis. Okay, here I am showing one example of how it can come, the question of the titration. So determine the concentration or molarity of KMnO4 solution by titrating it against a standard solution of, and it would be molarity would be given like standard solution ki molarity would be given like m by 10 or m by 20, like something. So you should be ready for it, and it can be standard solution of oxalic acid or the ferrous ammonium sulfate, which is more salt. Yes. Then we come to the qualitative analysis, or you can say salt analysis. So we have the cations. These all are the cations. These all are the anions which are present in a syllabus. So look upon all this. Look at once, and yeah, here's a tip that look for the solutions or the pair of salts like this in your laboratory, in your school laboratory, so you can know which salt you will be given or the probability of how many salts you can be given, so you can study well. Next we come to the functional group test. Which are the functional group test? इसमें mainly होते हैं, this is a carboxylic acid, this is a ketone, this is an aldehyde, and wait, let me focus. This is double bond, triple bond, means these are of unsaturation. Is the nitro group, phenol and alcoholic, OH group, then amine group. It is of amine is of primary actually. Then we come here, first of all, the volumetric analysis, and it's of titration. Then here I have written the KMnO4 with the oxalic acid. So first part is of I'm taking the oxalic acid. So for example, if it is given to me कि ये standard solution है 250 ml of 0.1 m. 250 ml, or you can achieve you can get 100 ml, or you can get 200 ml. It depends upon the titration flask, the school, which titration flask the school has. Okay. Then this is your oxalic acid given, this ml of this molarity. Now we come to the oxalic acid. What is the molecular mass of oxalic acid? You know the formula of oxalic acid is this. So calculating all the molecular masses of the each element in this, we comes to know that the molecular mass of the oxalic acid is 126 gram per mole. Okay, and you might learn it because it is repeated many times in your practice, in your practical, so you might want to learn it for the further reduction of the time and good impression of the practical on your examiner, external examiner. Then we come here the volume molar. Okay, I have made a table like this because it would be easier for you to know how the calculation is done and how do you know how much gram, in how much gram you have to take the oxalic acid to prepare a salt of oxalic solution and to titrate it against KMnO4. So here I've written 3 columns. First is of volume, which is in ml. Listen here carefully, which is in ml. Molarity, which is in m, means mole per liter. Mass in gram. So if I know it correctly, then 1000 ml, as you know the formula of molarity, it includes 1000 ml, 1 molarity and molecular mass of the oxalic acid, which is 126. So I have written 126. Second rule says that 250 ml would 250 ml of 0.1 m would require how much mass? So it would be 126 into 250 into 0.1 and divided by 1000. Why divided by 1000? Because 250 is in ml and we have to check it out in liter. Okay, in this standard form. So we got here 3.15 gram of oxalic acid to be prepared. This is as important as this year the examiner और the practical might want to ask. Practicals में question आ सकता है कि you have to weigh yourself, means कि you have to weight it yourself, the mass, the grams, the mass of the solute means your oxalic acid. Then next calculation, supposedly we have know this mass, and then after know this, I want to wait. Okay, this is a procedure of the titration. Here I'm showing you this. You can see the titration process in your lab manuals, and if you don't know, please comment down so that I can make a yes, it's a procedure of titration. So yeah, please comment down so that I can make a new video on that topic. Yeah, it would require a whole detail of the titration and how much you need H2SO4, how much of the titration flask and all of that. So for the correct information, if you need it, I can make a new video. And yeah, one benefit of making my videos right now is that I am in class 12, so I know how to look upon each thing, and yeah, I've experienced everything and I've asked my teachers, and yeah, and I've done my whole like research on it before making a video. So don't hesitate to look upon my video because I'm not a amateur. Yeah, I've researched and it's a foolproof guarantee that what I'm saying is all correct. Okay, so next comes out to be the next calculation part, which is the, if you know before that what titration and all of this, you might just see it as a short notes, which I have also made it as short notes. But if you want a whole process of it before all of this, and if you like you don't know or anything of the titration, so I might suggest you a video or a link. So I would post it in the description box. Please check it out if you are willing to study this titration in detail. Okay, so yes, come on. So volume of the oxalic acid. Acha, here we have the titration when we add the H2SO4 in the titration flask or in the conical flask. Then we measure the volume of H2SO4 as equal to the oxalic acid pipetted out by the titration flask into the conical flask. So it is equals to the 20 ml here, but it can vary as along if your school has a 10 ml titration flask or conical flask, so it may vary. Okay, so here I have taken as a 20 ml. Then molarity of oxalic acid which was given, so I had written at 0.1 m. And volume of KMnO4, where ये कहाँ से आया वॉल्यूम ऑफ KMnO4? ये हमारा टाइट्रेशन से आया. टाइट्रेशन से जब हमने ब्यूरेट से वो नीचे रीडिंग्स करी तो कॉन्कॉर्डेंट रीडिंग हमारी ये 16 ml. Then we look up to next is the, yes, here is the formula, and it's a modified formula of M1V1 equals to M2V2, which is the law of dilation. So here is a modified formula, and it's easy as per through my research for the calculation part, because it just the things are very straightforward and you can easily apply to it. यहाँ पे फॉर्मूले आपको बहुत सारी चीज़ें देखनी पड़ती थी, बट है नॉट. ठीक है, सो फर्स्ट ऊपर वाले केस में न्यूमरेटर में है कि वॉल्यूम ऑफ KMnO4 इंटू वॉल्यूम ऑफ molarity of KMnO4 upon volume of oxalic acid into molarity of oxalic acid. And you know volume into molarity is equals to the number of moles. So here I have written is the number of moles of KMnO4 and moles of oxalic acid. So the values which I have written here are to be put it down in this table, that 16 is the volume of KMnO4 into molarity of KMnO4 upon 20, which is the volume of oxalic acid into molarity of oxalic acid which was given, so upon 0.1, and 2/5 here comes out from the Ionic equation. Yes, here I have written the Ionic equation. I would tell you how to remember and all that. See how many moles of MnO4 minus are reacting to. So I have written here as 2. How many moles of this oxalic acid is reacting? That's 5, so I've written as 5. Then we come mole. It's not mole, it's a molarity. Molarity of KMnO4 solution which was not given, so this was the quantity to be find out, and it comes out to be 0.05 m. So molarity we know, molar mass we know, strength is the formula of molarity into molar mass. So how much it comes out to be? 0.05 into 158 comes out to be 0.9 gram per liter. So please remember the SI unit of the strength. So my question में आ सकता है कि it is not the concentration is 7.9 gram per liter, but it's not the concentration, it's our strength. Then we come to the Ionic equation. Ionic equation basically it's the equation which involves the electrons. Okay, there is also another equation which is molecular equation, but that doesn't need to be remembered. It's a whole lot of rattabaji and you don't have to remember that, please. So yeah, but this is all important and you will find easy to learn it, because I have learned it in like 10 minutes or 20 minutes. You would find it easy. Just write it down and just remember it, and yeah, please repeat it 1 to 3 times and you would remember for the 2-3 days. आगे के लिए learn करने के लिए then again revise it in the next coming week or something like that. But no, if you would revise it for the after a month, again you will revise, again you will remember it correctly, because this is not a thing to be remembered. Like, yeah, you in class 12th, you've learned so many things before, so what is this in front of that? Okay, rest all this. Ionic equation, देखो, Ionic equation which is for titration of the KMnO4 and oxalic acid. So always remember that KMnO4 acts as a oxidizing agent and oxalic acid reacts as a reducing agent. So ये क्या करेगा, ऑक्सीडाइजिंग एजेंट है, दैट मीन्स इट विल रिड्यूस एंड इट विल ऑक्सीडाइज. So here we will see, and in class 11th we have learned that MnO4 माइनस, यहाँ पे इसकी ऑक्सीडेशन स्टेट होती है +7, किसकी, Mn की, और यहाँ पे कितनी है, +2. सो ये हो रहा है हमारा रिडक्शन एंड यहाँ पे हो रहा है ऑक्सीडेशन. तो हमने इसको इलेक्ट्रॉन्स इक्वल करने के लिए हमने इसको मल्टीप्लाई करा एंड देन वी गॉट दिस इक्वेशन. अगर आपको देखना है तो इसका स्क्रीनशॉट ले सकते हो. पीछे के पेजेस का भी स्क्रीनशॉट ले जा सकते हो आप. Okay, come next to the titration second part, which is KMnO4 titrated against the Mohr salt. What is a Mohr salt? It is ammonium ferrosulfate, or you can also write it as FeSO4 dot NH4 whole twice SO4 dot 6H2O. It's so easy. See, SO4 यहाँ पे Fe और यहाँ पे NH4 और whole twice and then 6H2O. यहाँ पे रिमेंबर करो कि यहाँ पे 6H2 है, ऑक्सैलिक एसिड में 2H2 थे. Then here I am writing it as aim. यहाँ पे भी सेम है बट हमने मोलरिटी चेंज करी है. वहाँ पे 0.01 था, here we got the 0.05. That means the molarity is m/20 of the Mohr salt. Okay, m/20 कैसे, इसको पॉइंट डेसिमल हटा के पॉन में 100 करो, so you will solve it and get it by m/20. Molecular mass, what is the molecular mass of all this Mohr salt? It is 392 gram per mole. Okay, it's 392 gram per mole. Then again we have made the three tabular system, and first is the columns of volume, which is in ml, molarity, then mass. See, 1 molarity means 1000 ml, and it contains the molecular mass which is 392. So 250 ml the molarity of 0.05 would contain 392 into 250 into 0.5 and upon 1000. It is 4.9, and I told you कि how it is 250 and 0.5 and 100 कि उसको multiply क्यों करा, इसको divide क्यों करा. I've told you before. Okay, so basically this formula is कि molarity of the solution कहाँ से आएगी इसकी molarity of solution, ये molarity of solution into molecular mass of the solute and then volume of the solution in liters. So ये है basically ये formula ये जो मैंने लिखा है. So in short you have to remember it. So remember this. Yeah, you can take the screenshot. Okay, coming to the next page, we've got the determination. Yes, this is the question actually. Determination of the strength of KMnO4. Yes, usually the strength is asked so many times. Strength of KMnO4 using standard solution of Mohr salt. So KMnO4 हम burette में डालते हैं up to the 0 mark. Oxalic acid solution with the help of pipette to conical flask. And add a full test tube which is of 20 to 25 ml of dilute H2SO4 which is of nearly 20 ml. That's why we took the 20 ml of the oxalic acid also. So these titrate till permanent pink, which is the end point. Here I've shown you the different thing which I've not shown you for the oxalic acid. Here I've shown you how you can calculate the volume of the KMnO4 using the titration techniques. So it's a little sneak peek to that. You can also learn how you have to write, like first columns of serial number, then initial burette reading, then final burette reading, then volume of KMnO4 used or consumed, then it's concordant, so 0 to 21.2, 21.2 to 42. Usually 3 readings are written, but हम practice और जो वहाँ पे actually में practical करते हैं वो हम 2 ही के लिए करते हैं, and third reading is written from our side to make it easier and to make it less time consuming. Again we have written as the volume of Mohr salt same as 20 ml because the test tube is of 20 ml. Molecularity of the more salt which is given, volume of KMnO4 solution which is 21.2 ml. Okay, and here I have written the formula like is before, so please see this formula once again. Just the oxalic acid is changed by more salt and nothing else. Okay, here comes out to be 2 by 10, you know the from the ionic situation equation, क्योंकि इसको into 2 करोगे equation को, तो here would you get 2 and here you would get 10, तो 2 by 10 लिखो या 1 by 5 लिखो, it's equal. ठीक है, and from the solution we got the molarity of the KMnO4 solution to be 0.094 m, and we know molar mass and molarity, so hence we can get the strength of the given KMnO4 solution, which is this into this, and we come now to be known that it is 1.4852 gram per liter. Then here comes the ionic equation. Again MnO4 की same equation है, Fe2 plus, yes this were more salt, तो यहाँ पे Fe2 plus ferrous to ferric convert होता है, and then we balance it by multiplying it 5, and then this is the equation. These are some of the keynotes and I have written. If you would like to, then please take a screenshot. Okay, now I'm going to teach you how it is. Note, देखो, in class 12th टाइट्रेशन जो हम पढ़ते हैं दैट इज ऑफ रिडॉक्स रिएक्शन, मतलब कि हमने देखा कि यहाँ पे KMnO4 हो रहा था रिड्यूस, और जो दूसरा था ऑक्सैलिक एसिड और मोर सॉल्ट दैट वाज एक्चुअली ऑक्सीडाइज्ड. यस, so since we can say it's a redox reaction, and here KMnO4 acts as an oxidizing agent. It's a titrant. Titrant क्या होता है, जिसको हम ब्यूरेट में लेते हैं, जिसकी नॉन स्ट्रेंथ होती है. सेल्फ इंडिकेटर, मतलब ये पिंक दिखा देता है, हमें इस टाइट्रेशन प्रोसेस में कोई भी इंडिकेटर यूज करने की जरूरत नहीं होती है. एज यू रिमेंबर्ड कि क्लास 11th में हम फिनोफ्थलीन यूज करते थे एज अ इंडिकेटर, बट नो हम यहाँ पे यूज नहीं करते हैं बिकॉज KMnO4 इज अ सेल्फ इंडिकेटर. जो हम KMnO4 लेते हैं यहाँ पे जो हम लेते हैं, दिस इज ऑफ वॉयलेट कलर, and Mn2 plus is changes to colorless. Okay, then dilute H2O4 क्या लिया जाता है, to make acidic medium and prevent hydrolysis of what, ऑक्सैलिक एसिड और मोर सॉल्ट. ठीक है, then we take the oxalic acid and more salt as they are the reducing agent and they are known as the titrant, जिसको हम पिपेट में लेते हैं. नॉर्मेलिटी का फॉर्मूला होता है कि हमने स्ट्रेंथ की उसमें लगाया है कि नॉर्मेलिटी का फॉर्मूला क्या बन सकते हैं, तो दैट स्ट्रेंथ अपॉन इक्विवेलेंट मास ऑफ सॉल्यूट इन ग्राम, molarity equals to the strength in gram per liter upon molecular mass of solute in gram. And if you want to look upon a relation upon equivalent mass and molecular mass, so equivalent mass और molecular mass में क्या होता है कि equivalent mass is molecular mass divided by number of electrons gained or lost per molecule. And here comes the very important table which I have made, and it's so important for me. See, this is the substance. Means first I've taken the KMnO4 in the acidic medium. So formula is KMnO4. Molecular mass is 158. We all know. Equation acidic medium की होती है कि जहाँ पे 5 electrons होते हैं. So equivalent mass क्या होता है? Molecular mass upon में जितने भी electrons gained हुए तो यहाँ पे 5 हुए तो 158 upon 5 that is 31.6. ठीक है. नेक्स्ट वी टेक इट ऑफ बेसिक मीडियम. सो बेसिक मीडियम में ये यहाँ तक सेम है, बट equation changes and it involves only 3 electrons. So divided by 3 we got 52.6. Its equivalent mass. Okay? We talk about oxalic acid, which is formula is this C2O4H2.2H2O, and the molecular mass is 126. So equation involves 2 electrons, divided by 2 we got 63. More salt का formula is this FeSO4.NH4 whole twice is 4.6H2O. Molecular mass is 392. Equation is something like this, which involves the 1 electron and it is 392 as always. Okay. One another relation which I wrote it as M1V2, and this it could be written in as in a normality also. Okay. So guys, thank you for all coming to this page, and yeah, it is all I want to help you out. Yeah, take a screenshot of this, which is a good page, and I have understand it as it's really good. If you are in 12th, it might help you, and if it might helps, please comment down, please let me know that this video was helpful, please. I think you might have took the screenshot. Then the next we are going to look upon is the I think you would mind to read this. Please take a screenshot of it. Yes. It's not focusing. Yeah, this was the table which I written from. Yeah, that's example. If you would like to read, it could help you. Okay, take a screenshot of it also as well. Then next the thing is, okay, next are, as always, you can look upon your practical file, है ना. अपने टीचर्स से पूछ लेना, उन्होंने प्रैक्टिकल फाइल कोई अच्छे बच्चे की कॉपी आउट कर लेना, तो दैट वुड हेल्प यू. And if you are the अच्छा बच्चा, then there is no point of doubt. Please take a screenshot. These are some Viva questions. Might help you. So the ticked questions are somewhat I have listened from some students, from some teachers, so they are usually asked. Oh, so till here, bye bye. Good to see you again.